Today's lesson is about transforming nonlinear regression into linear regression. As we know, for the linear regression equation y equals a plus bx, we can use this formula to figure out the correlation coefficient r and the y-intercept a and the slope of a linear regression equation b. But for some data which is clearly nonlinear, in some cases we can transform the data into a form where we can use linear regression. First of all, let's talk about a logarithm model. A logarithm model has the form y equals a plus b natural log of x. We can consider natural log of x as a variable. So there is a linear relationship between y and the natural log of x. For example, this data has a logarithm model. But if you draw the graph for x, it's not x anymore, it's a natural log of x. This is the y. Then you will have a linear relationship model like this. In other words, the relationship between y and the natural log of x will be linear model. Let's go to exponential model. An exponential model has the form y equals k times p to the x power. For k greater than 0 and p greater than 0 but not equal to 1. Transfer this form y equals k times p to the x power into linear model. First of all, we will do natural log both sides. So you have natural log of y equals natural log of k times p to the x power. So we can expand this natural log as natural log of k plus natural log of p to the x power. Keep simplifying. We have natural log of k plus. We can drop this x to the front, so x times natural log of p. Then we can set up the a equals natural log of k, b equals natural log of p. Therefore, you will get natural log of y equals a plus bx. From this equation, you could say there is a linear relationship between natural log of y and this x. If the data between x, y is an exponential model like this, can transform this nonlinear model into linear model this. The x won't change, but for the y coordinate, I will do natural log of y. In this way, you will have a linear model. Suppose you already get the relationship between x and the natural log of y like this. Natural log of y equals a plus b to the x power. How can you change back into exponential function? You will both sides do the is power. Since e to the natural log of y equals y, so you will get the y equals e to the a plus bx power. Then you will get the e to the a times e to the b x power. E to the a's power, we can go back into k. For this, you can consider as e to the b's power x power. Therefore, you have p times x power. In this way, you will change this linear regression line into exponential model. Let's check a power model. A power model has a form of y equals p times x to the nth power, p greater than 0 and n not equal to 0. For this power model, we can change into linear model by doing natural log of both sides. We expand this natural log as natural log of p plus natural log of x to the nth power. Then we get natural log of p plus, take this n to the front so that you will get the n times natural log of x. Here's natural log of y. Then we can set up natural log of p equals a, n equals b. Therefore, you will get the natural log of y equals a plus b times natural log of x. From this equation, you could see clearly natural log of y and natural log of x have a linear relationship. For the graph, the relationship between x and y is a power model. But if we draw the graph between natural log of x and the natural log of y, you will get a linear model. Will be like this. Remember, all power models pass through the origin. Remove the 0, 0 before analysis. Suppose we got the linear regression line like this. Natural log of y equals a plus b times the natural log of x. We want to transfer this equation back to the, first of all, both sides we do e's power. According to the formula, a to the log base a to the x power equals x. We got the left side is y equals e to the a times e to the b times natural log of x. Because e to the a's power times e to the b's power equals e to the a plus b. We do the backwards, we got this. Then according to this formula, n times log base b to the x power, we can jump this n as a exponent of x so that you can get the log base b x to the nth power. We can jump this b as exponent here so that you will get the e to the a's power times e to the natural log of x to the b's power. For these expressions, we use this formula again. You will get the x to the b's power here, e to the a's power. So you have y equals e to the a's power times x to the b's power. Let's make p equals e to the a's power and n equals b. So we get the y equals p times x to the nth power. This will be the power model